Prior to this lesson video, we tackled about the 6 trigonometric ratios, namely in mnemonics, the SOHCAHTOA. For this video, we will illustrate the domain and range of the basic trigonometric function, determine their amplitude, and sketch the graph of the function. Before discussing the first topic, let us first be acquainted with the following set notation. The following sets are totally different from each other. They differ in the use of the parentheses and bracket. Take note that if we are using parentheses, that means to say that such number is not included in the set. And if we are using a bracket, that number is included in the set. For given A, the given A is both parentheses. So therefore, this is a set of all numbers from 5 to 8, but 5 and 8 are not included in the set. So what are these numbers? In that set, we can have 5.1, 5.2, 5.3, and so on until 7.99999. But 8 is not part of the set. For the second set, that is the set of all the numbers from 5 to 8, where 5 is not included but 8 is included in the set. For our third set, the set of all numbers from 5 to 8, where 5 is included but 8 is not included. And for the last set, the set of all the numbers from 5 to 8, where 5 and 8 are included in that set. For second set, we have this infinity symbol. If we are using infinity, since we don't know the last number of the infinity, therefore, our set should be in parentheses. We cannot use bracket for infinity. So for the first, a set from negative infinity to positive 3, where 3 is not included. For the second, this is a set of all the numbers from negative infinity to positive 3, and 3 is included. For the third, this is a set of all the numbers from positive 3 to positive infinity, and 3 is not included. And lastly, this is a set of all the numbers from 3 to positive infinity, and 3 is included in that set. So the only difference is that if we are using infinite symbol, our set should be in parentheses. And if a number is included in the set, we will be using the bracket in its bound. And if the number is not included in the set, use parentheses. To begin with, recall the following information taken from the figure. Take note that sine theta equals y, and cosine theta equals x, and tan theta equals y over x. We will now illustrate the domain and range of these functions. By definition, domain is a set of all the possible values of the independent variable, and in the case of the circular function, these independent variables are the values of the theta. For example, we can have the cos of the pi over 6 rad, the pi over 4 rad, pi over 3 rad, and pi over 2 rad. And we can continue this sequence. We are not only after for some values of our theta. We are encompassing all those possible values. On the other hand, the range of the function is the set of all the possible values of the dependent variables, which is the value of the circular function. For example, for cos pi over 6 rad, that is equal to square root of 3 over 2. For pi over 4, square root of 2 over 2. For pi over 3, we have 1/2, and for pi over 2, we have 0, and so on. These are only a portion of all the possible values of the circular function. Range is the collection of all those values. In order to understand better this concept, I will show the graph of the function to visualize their domain and range. These graphs are not mine. They are taken from the Google, and all the rights and privileges of these materials belongs to their respective owners. This is the graph of y equals sine x. The graph of the sine function is infinite. It will extend in both directions. The domain can be observed in the x-axis and the range in the y-axis. Look at first the x-axis. Since the graph will extend both to the right and to the left, it means that there is no limit as to the angles. Hence, the domain as the set of all the angles in sine function is this. The theta is an element of real number. If you can see this kind of set, it means to say that all the possible values of theta which are under the real number system are part of the domain. Look at now the y-axis. The highest point of the graph is at y equals positive 1, and the lowest point at y equals negative 1. And all the points in between the positive 1 and negative 1 are parts of the graph. Therefore, the range of the sine function is this. Since those values are from negative 1 to positive 1, so the range is a set containing the numbers from negative 1 to positive 1, where negative 1 and positive 1 are included in the set. Let us now proceed to the cosine function. For the domain, look at the x-axis. The same case with the sine, in both directions the graph will extend. Therefore, the domain for our cosine function is the same as with our sine. For the range of the cosine function, the highest point used in y-axis is positive 1 and the lowest negative 1. With that, the range of our cosine function is a set containing negative 1 to positive 1, including the two numbers. We will now proceed to the graph of our tangent function. For the tangent, observe in the graph that it is not continuous. The graph of tangent is somehow divided by a certain line, one after the other. For the domain, note that not all points in x-axis are utilized by the graph. For instance, the pi over 2, 3 pi over 2, and etc. In pi over 2, we cannot have any values for tangent, primarily because at this point, tangent is undefined. Let us now get the set notation of each domain. Take note that tan theta equals y over x. There is a restriction for tangent to make it well defined. The denominator must not be equal to 0. Since the denominator is x, any point on the circle whose x-coordinate is 0 constitute the restriction of its domain. Observe this graph. The points with 0x coordinate are the pi over 2 and 3 pi over 2. At that point, the tangent is undefined. The angles may go beyond 360 degrees or the reverse, which have negative angle measure. Suppose the circular movement continues. What would be the next undefined points for tangent? It is 450 degrees or 5 pi over 2 with these coordinates. This is also true for negative angles. For the domain, we need to undergo some process. Take note that the first undefined point is pi over 2. And from this pi over 2, we will simply add another pi, resulting to 3 pi over 2 and another undefined point. So meaning to say, from this initial point, we will always add something pi so that we can have another undefined point. After that, we can add 2 pi, 3 pi, and 4 pi. And we will assume all those numerical values of our pi as the k. So what is this k? This k is any integer. So it could be positive integer or negative integer. This is the restriction of our domain for the tangent function. For the range of the tangent function, those arrowheads represent the extension of the graph without bound. positive y, and negative y infinitely. Therefore, the range is from negative infinity to positive infinity. The next graph is the graph of our cotangent function. Observe that they have the same range just like the tangent function, that is from negative infinity to positive infinity. Let us now get the domain of the cotangent function. Note that cotangent theta equals x over y. The restriction now is that the y-coordinate must not be 0. From that graph, 0 degree has a coordinate of 1, 0, and the pi rad has negative 1, 0 coordinate. Both points have 0 y-coordinate. So, cotangent is undefined at these points. Next to pi rad, by adding a semicircle pi, 2 pi has the coordinate 1, 0, is the next undefined points of the cotangent function. Next to 2 pi, by adding again another pi, is 3 pi, 4 pi, and so on. Therefore, the domain is this. So the theta should not be equal to k pi, where k is any integer. Observe now the graph of the second function. The very observable feature about its graph is the range. Observe that starting from positive 1 upward, all the points from positive 1 to positive infinity are part of the graph, but not including below positive 1. In the same case, at y equals negative 1 downward, negative numbers from y equals negative 1 are also part of the range. Therefore, the range of our second function is this. That is the union of the set of points from negative infinity to negative 1, including negative 1, and from positive 1 to positive infinity, including positive 1. For the domain of the second function, if cos theta equals x, secant is the inverse of the cos theta. So we have secant theta equals 1 over x. There is now the restriction for our denominator. The secant is undefined when x is equal to 0. In this graph, x coordinate is 0 at pi over 2 and 3 pi over 2. Similar case with the tangent function, the domain for our second function is this. The theta should not be equal to pi over 2 plus k pi, where k is any integer. And for the last circular function cosecant, this is its graph. The graph has almost the same figure with the graph of the second function. For the range, it behaves similarly with second function. Therefore, the range for the cosecant function is this. For its domain, let us analyze its nature. If sin theta equals y, and since cosecant theta is the inverse of our sin theta, therefore, for the restriction, our y should not be equal to 0. Because of that restriction, cosecant is undefined in pi and 2 pi since their y-coordinate is 0, as what happened to the cotangent function. Therefore, the domain for the cosecant is this. The theta should not be equal to k pi, where k is any integer. We will now proceed to the graphing of the sine, cosine, tangent, and the cotangent function. The sine and the cosine functions are periodic functions because their values will repeat at a regular interval. For example, the 2 pi. After the interval of the 2 pi, the value of our function will repeat itself in the second cycle. Consider now this equation. Remember that the value of our A is the amplitude. The amplitude is the height of the curve from its axis. And usually in the graph, the x-axis is the axis of function. So this A represents what is the highest and the lowest point of the graph. The value of our B will be used to solve for the period. And this period will represent the complete cycle of our function. And lastly, the value of our c is a phase shift. This value makes our graph shifted either to the left or to the right of our original function. And since the regular interval of the sine and the cosine function is 2 pi, to solve for our period, that is 2 pi divided by the absolute value of our b. To sketch the graph of these functions, steps are provided in the module. We will go directly to the example. Sketch the graph of y equals 3 sine x. I will be showing the step-by-step solution in graphing this function. For y equals 3 sine x, we need to identify the values of our a, b, and c. And from that given, our a is 3, the b is the numerical coefficient of our x, which is 1, c is 0. From that given, we can now identify our amplitude as well as the period. And accordingly, amplitude is the value of our a, therefore, the amplitude is 3 units. That means to say from the x-axis, we will be using points 3 units up and 3 units down. For our period, that is 2 pi over the absolute value of b. And since the b is equal to 1, so the absolute value of 1 is 1, therefore 2 pi divided by 1 is 2 pi. Before we can graph this function, we need first to divide the interval from our 0 until the period of 2 pi. Look at this unit circle. The 2 pi is the 300 degrees and the 0 is the 0 degrees. So how to get the 4 equal parts of this interval? You are going to divide the middle of the points. For example, from 0 to 2 pi, and 2 pi is 360 degree. So the middle of the 0 and 360 is 180. And 180 is pi rad. So we have that pi on the third point. And from 0 to pi, that is 0 to 180. What is half between 0 and 180? So the half is 90. And 90 in radian is pi over 2. And lastly, from 180 to 360, half of that is 270 degrees. And that is equivalent to 3 over 2 pi. That is how to get the points for our x. This time, we are going to evaluate each value of our x in our original equation y equals 3 sine x. For the first value of x, which is 0, that becomes y equals 3 sine 0. So what is sine 0? By using your hand, this is the 0. Sine 0 is square root of 0 over 2, and that is equal to 0. And 3 times 0 is 0. Let us now proceed to the x equals pi over 2. 3 times sine pi over 2. Remember that the sine theta is equal to our y coordinate. And the pi over 2 or the 90 degrees has the coordinate of 0, 1. And the y coordinate of that 0, 1 is 1. Therefore, sine pi over 2 is 1. 3 times 1, so your y is 3. For our x equals pi, y equals 3 sine pi. And the coordinate of our pi is negative 1, 0. Therefore, the y coordinate representing the sine function is 0. So 3 times 0 is 0. We will now proceed to our x equals 3 over 2 pi. For our x equals 3 over 2 pi, the coordinate of our 3 over 2 pi is 0, negative 1. So the y coordinate is negative 1. So we have 3 times negative 1, that is negative 3. And lastly, the 2 pi. The coordinate of our 2 pi is 1, 0. So the sign is 0, the y coordinate. So you have 3 times 0 is 0. After completing the table, we can now graph this function. We will now plot the coordinates of our points. So the first is 0, 0. So that is in the origin. The second coordinate is pi over 2 and 3. So the pi over 2, the y coordinate is 3. So this is our point. For our third coordinate, pi and 0. So the y coordinate of our pi is 0. For the fourth, 3 over 2 pi, that is negative 3. So 3 over 2, so this is the point. And lastly, for the 2 pi, 0. So this is the point for the 2 pi, 0. And after that one, we will connect these points using a smooth curve. That is a complete cycle of the graph y equals 3 sine x. And there is no need for us to extend the graph since we are asked only to graph for a one cycle. But if you are asked to graph 2 cycles of a certain function, then you need to extend. So what will be the endpoint of the second cycle of this graph going to the right? So since the period is 2 pi, so you will add another 2 pi going to the right so that you can create another cycle of this graph. And for the second cycle, the same formation the first one. Because sine function is periodic, so the points will repeat itself after a regular interval. For our second example, in the same Cartesian plane, sketch one cycle of the graph of y equals 3 sine x plus pi over 4. Get first the values of our a, b, and c. For our values of a, b, and c, so this is the value of our a. For our b, the numerical coefficient of our x, that is 1. And for our c, this is negative pi over 4. Why negative pi over 4? Because in the original equation, this part should be in the form x minus c. And since that is positive, that is equal to x minus the negative of pi over 4. Therefore, the value of our c is negative pi over 4. So we will now graph this second function. So the dotted line is the graph of our second equation, which is y equals 3 sine x plus pi over 4.